Welcome back to Ask Swagelok. My name's Kevin McClelland. I'm here with Matt Dixon, Global Technical Lead. We are in the Custom Solutions building on Swagelok's Solon campus today, and we're going to talk about viscous sampling and some design considerations. So, Matt, can you describe viscous sampling and why it's so challenging?
Sure. Viscous sampling, first of all, is known by a number of different names. It could be residual sampling or resid sampling, or more commonly, it's known as bottom sampling. And that comes from the refining industry, where we're sampling the hot oil that's coming out of the distillation tower. And that oil is coming out at really high temperature. It could be 500, 600, 700 degrees. And so with that temperature comes some real big safety concerns. And we can't even let it cool down all that much, because if we do, it's going to start to solidify and it could potentially plug up our system. So as a result, we need to keep it hot. We generally need to keep it flowing, but above all, we need to keep it safe. So those safety concerns are going to be paramount. And that's compounded by the fact that a lot of times these viscous samples have gas trapped inside of them. So as we're dispensing the sample, it could be spitting and spittling a little bit, potentially splashing the operator. So again, some big safety concerns.
What should we keep in mind when we are designing a sampler for these viscous liquids?
The first consideration is going to be safety. We want to make sure that the operator is safe when they're doing this. So we're going to look at things like insulating the hot surfaces to make sure that they can't accidentally touch something that's hot. Protecting the operator from splatters, so putting it inside of an enclosure so that they don't have the opportunity to get splashed. Also, we want to make sure that we keep that sample hot and we keep it moving. So normally, what we're going to do is have some sort of a fast loop arrangement where we take a sample from the process through a 1-inch pipe or tube to our sampling station and then return it to the process at some lower pressure point in the system. Now with that, we're able to keep that line nice and hot by steam tracing it, and we're able to keep the fluid moving because we don't want to have it stop and stagnate and cool down and potentially plug up. And finally, we want to make sure that we keep everything relatively simple in these sampling systems. With viscous sampling, keeping it simple with as few twists and turns as we possibly can have in the sampling system is going to make life a little bit easier for us, because the fewer twists and turns, the fewer places we have where the sample could potentially get hung up, cool down, and start to solidify and plug everything up. So we're going to do things like have nice swept tube bends instead of elbows.
You mentioned valves. What are some of the important characteristics of a valve designed for viscous sampling?
So first of all, the valve has to meet the temperature profile. Again, with the high temperatures of this sample, we've got to be able to meet those elevated temperatures. Beyond that, the valve has to have relatively large orifices because of the thick nature of the liquid. So having orifice sizes that are at least 1/4 inch in diameter, that's going to be key to making sure that we don't end up with plugs. Whenever we have a fast loop arrangement, it's going to be best to have an inline sampling valve. That way the hot viscous liquid can flow through the sample valve itself, which helps to keep the valve warm, minimize those cool spots, and prevent stuff from collecting in the valve and plugging up. And so as a result, that also provides us with a nice advantage of minimizing the dead leg between the sample that's flowing through the fast loop and our sample takeoff. So it's a double bonus for us in that situation. Beyond that, we also want to have a valve that we can purge so that we can keep it nice and clean. Using something like steam to purge out the valve after we take our sample is going to remove some of that residue, prevent it from building up that could potentially cause a plug over time.
Are there any special handling requirements for these viscous samples?
Yeah, once the sample leaves the valve, we've got to take it and transport it into some sort of a sample container. Usually, with a liquid, we're going to sample in some sort of a bottle, whether that's a glass bottle or a plastic bottle. Well, with this application, that's usually not an option because of the temperature considerations. So as a result, we're typically going to use some sort of a metallic sample container in this case. Here in the United States, the most common one that I've seen is actually a metallic paint can that you can get at the local hardware store. Relatively inexpensive and available just about everywhere. Another common one is just a screw top bottle made out of stainless steel. So lots of different options out there, but generally they're all going to be metallic in this application. Now actually dispensing it into that container, typically you're going to have some sort of a nozzle to do that. It could be as simple as a short tube stub coming from your final valve down to the sample container. However, if it's just a simple tube stub, you do run the risk of plugging up because that tube stub is not heated. So what we'll do sometimes is build what's called a stinger assembly. With the stinger, we actually use that same tube stub, but now we put a steam jacket around the outside of it. So that keeps it warm, nice to the tip. There are no cold spots. There's no places where it can potentially cool down, start to solidify, and plug everything up. Beyond that, purging the system after we're done sampling is also going to be key. Having that purge so that we can get all the residue out, that's really going to be beneficial. So from a sample purity perspective, and also from a maintenance and operations perspective, because we're going to be avoiding that plugging.
I want to say thank you once again to Matt for his wonderful technical expertise. This has been another episode of Ask Swagelok. We'll see you next time.